Now we're jumping into part 2 here, ladies and gentlemen. Get it. So I'm going to start by doing some review problems here. You can skip past these if you already know how to do all these. If you'd like the review, I don't think it could hurt. I really don't. But just going through these examples, hopefully. If you didn't want to just pause, go back and pause and, figure out what I'm doing. All right, so negative 27 breaks down to negative 1 times 9 times 3, and that's where this comes from. I did not forget the plus or minus. Have to have that as well. This is an x method problem. Factors into x minus 9, x plus 3. So I get two solutions. I get x is equal to 9 and x is equal to negative 3, because you set each of those equal to 0 and solve them respectively. And then last but not least, monster over here. I'm going to start by multiplying both sides by negative 8. So I get v plus 3 quantity squared is equal to negative 56. Kind of gross. I don't really like negative 56, but either way, I don't really have to. Square root both sides, you get v plus 3, and this is going to equal plus or minus. Got to remember that. Now, 56 is an odd one. All right, not odd because it's an even number, but it's negative 1 times. I don't think 16 goes into it, but I know that 4 does. It's 4 times 14. So this is the same thing as the square root of 4 is 2. So 2i root 14. Then you subtract 3 from both sides. And so our answer is going to look like this. Our answers are going to look like this. Negative 3 plus or minus 2i root 14. So 3 review problems under 2 minutes. I'm on a roll right now. All right, now we're multiplying here. This is what makes things a lot more difficult. All right, when we multiply, we still want them to be in a plus bi form, and that might mean some switching around at the end, but that's what we want. So I'm distributing. 5i times negative 2 is negative 10i. Then 5i times I would be plus 5i squared. Now, you think you're done, you're not, all right, because this is what's happening. The negative 10i is fine, but this one, we have an I squared. And I squared is always equal to negative 1. Just a review from the last one. You have to know that. If you have an I, leave it. I squared, you have to change it. So this is the same thing as plus 5 times negative 1. So this is a negative 5 right here. I'm putting that out front of the minus 10i because I always want my A number, my real number, to come first. So that's that. Now, over here, these problems right here will always get people because they will forget the steps and they will always forget and be lazy. So don't be lazy. Be on top of it. So here we go. We have 7 times negative 1 plus 2i. And then I have negative 4i times negative 1 plus 2i. So a lot of distribution here. Got to keep track of everything. All right, so this would be negative 7 plus 14i. And then I have positive 4i. And then I'm going to go take this many steps as I need here, negative 8i squared. Now the first thing I see is that these two can be combined. So that's going to be an 18i. Just getting those out of the way. Now the second thing I see, and I'm changing my colors because I want to alert you to this, is right here. This negative 8i squared is the same thing as negative 8 times negative 1, which would be a positive 8. Well, these two can combine now. Negative 7 plus 8 is 1. And since that's the real part, it goes out right in front, and you're done. But these two middle ones will always combine, ladies and gentlemen. So you make sure, take your time and do those right. Now, again, this is going to be 6 times 6 minus 3i. And then we take the second part here and distribute that. So plus 3i times 6 minus 3i. So we started with this, and then we did that. So 36 minus 18i plus 18i minus 9i squared. So I'm going to look at these two again. Now what happens? They go away. And I'll talk about this in a second. But we don't have to worry about anything there. That makes 0. This is negative 9 times negative 1. It should be a positive 9. So now all we have to do is take these two and add them. So 36 plus 9 is 45. It looks weird, but we just get a whole number here. Now, that's because these two look basically the same. The only difference is the sign. These are what's known as conjugates. All right? It's going to be very helpful when we're dealing with fractions. they have imaginary numbers in them, okay? But conjugates, if you multiply two conjugates, they turn into real numbers. We don't have imaginary anymore, okay? Okay, and the reason why is basically like when we were dealing with difference of two squares. If you have x plus 2, x minus 2, you end up with x squared minus 4, okay? That's because the two x terms go away, the middle terms go away, so it's kind of similar to that. Now over here, we have 2 and then negative 6 minus 2i, and then I have plus 3i times the same thing. So, I'm going to change my color here. I have negative 12 minus 4i, and then minus 18i, and then minus 6i squared. Now I'm going to take care of these first, because I know those will always combine. Negative 22i. Good. Now over here, I'm going to work on this. This is negative 6 times negative 1, which is a positive 6. Now negative 12 plus 6 is negative 6. And there's your answer. All right. Now I'm going to let these pop up real quick. And just as I explained before, can't end up having an imaginary number in the denominator. Can't do it. So that means, ladies and gentlemen, we have to get rid of this or make it look nicer. Kind of like when we had to rationalize the denominator. All right. So what we're going to do with these, I'm going to try to take this one slow because I have two more examples coming up, is multiply this by the conjugate of the denominator. This is a lot of work. That's why I have a lot of room here. We're multiplying instead of 2 plus 1 by 2, or sorry, 2 plus I, we're multiplying by 2 minus I. Okay? Over itself. Similar to if I had, let's see here, square root 5 over square root 2. We would multiply by root 2 over root 2. Now we get root 10 over 2. That's no longer a radical anymore. That's what we want here. It's just now we're trying to get rid of the imaginary part from the denominator. Just trying to get rid of it. Okay. Now, I'm going to try and color code. The top is going to be in orange. All right. So follow along with me. I'm going to put my final answer down here. But this is going to be 4, since this is 4 plus 3i. 4 times 2 minus I plus 3i times 2 minus I. That's going to be 8 minus 4i plus 6i minus 3i squared. So that's 2i, I know that. And this would be negative 3 times negative 1, so it'd be plus 3. 8 plus 3 is 11, so 11 plus 2i. Don't forget, I got the 11 from 8 plus 3. And that's my numerator. Great. Now it's okay to have an I here in the numerator. That's fine. I should, since I'm multiplying two conjugates, get rid of the imaginary part in the denominator, which is why we did this in the first place. So it'll be 2 times all that, and then plus I times all that. So I got 4 minus 2i plus 2i, and then minus I squared. Now this is kind of a weird one, but just like we wanted, those two go away. They make 0. Now this is not 0 right over here, though. This is going to be the opposite of, and I squared is negative 1. So it's the opposite of negative 1, which is a positive 1. 4 plus 1 is 5. So we have completely taken care of that fraction. Okay, and we don't have an imaginary part in the denominator, which is super important. Okay, this might be the only example I get to today besides the one I just did. I just did one, wait. That one had a 2 and an I. This is a 1 and a 2i. Is this negative? Yeah, I'll do this one then. That's fine. Okay, so we have to multiply through by the conjugate. All right, so I'm going to start there. And we want to multiply by 1 plus 2i and 1 plus 2i. All right, same thing as this, just different sign. All right, so I have that, and I'm going to put my answer down here. So I have, starting with the numerator in red, so 5 times 1 plus 2i, and then plus 3i, and then 1 plus 2i. So this is going to be 5 plus 10i plus 3i, and then plus 6i squared. Have to be careful there. So that's going to give me my 13i, and this is 6 times negative 1, so that gives me negative 6. 5 minus 6 is negative 1, especially on Wednesdays. Okay, so that's my numerator. Woo! Now, did some purple. No, I can't do purple, can I? Come on, tighten up, Mr. Byrne. So, my denominator is going to be in green. I'm going to have 1 times all this, 1 plus 2i. And then I'll have minus 2i times 1 plus 2i. So I get 1 plus 2i minus 2i, and then minus 4i squared. These two go away like we wanted it to. This is negative 4 times, instead of I squared, negative 1. So it's plus 4, 1 plus 4, 5. Boom. Boom.